Let's now dive deeper into the issues of static types and expectations. And we will consider two further examples. One is about the student management system that we are familiar with. Another one is the so-called smartphone example, which I will guide you through as well. Let's take a look at the first one. So I call that the multi-level inheritance architecture. So rather than just having like a two levels, you guys remember the old example we got students, under which we got resident students and non-resident students, only two levels. But now, in general, you may have as many levels as you like. So that's actually more realistic architecture to actually simulate the reality. In which case, you got a multi-level hierarchy between the entities. In which case, inheritance will be the best solution. Let's take a look at the first one. The first one here, let's say at the top we got the common parent class we set at the top of the hierarchy. So you can think about this one here. It's the top or the root of the hierarchy. Okay, so you can say either it's the top or the root of hierarchy. So under the students, we got domestic versus foreign. And under domestic, we also got domestic residents and also domestic non-resident. Under foreign, we got either foreign residents or foreign non-residents. So just for example, over here. And for this hierarchy here, I would like you to think about three reflective questions with respect to the three designs that we spoke about earlier. For design number one, if you recall, we actually use an integer attributes called kind to encode the kinds of students that we have in the hierarchy. So in this case, we actually got domestic residents, domestic non-residents, foreign residents, and foreign non-residents. So in this case, we might simply say this will be 1, 2, and 3, and 4 for the magic number value for the kind. And so we got how many encodings? In this case, we get 4, for example, just to represent the bottom 4 classes on the hierarchy. And how do we check for in each of the methods? Remember how this design violates the single choice principle. In every method, in order to define the correct behavior, we have to know what the current context object student's object is. So if it is happens to be domestic residents, in which case the kind is equal to 1, we got to do something. In case where the context objects is actually whose kind is actually equal to 3, in that case we have to do something according to foreign residents. So more precisely, for design number 1, you have to write something like if the kind equals 1. In that case, you'll do something over here. You will say else if kind is equal to 2, and then you do something, and that's the case for the earlier version for design number 1. But now that we actually got more kinds of students, so you got to continue with this else if until you go to the last one. In this case, it will be kind is equal to 4. In that case, you got to do something different, and you have to repeat this particular structure for every method to make sure it has the correct behavior according to the kind of students you're talking about. All right, so that's for design number 1. I want to remind you. What about design number 2? For design number 2, it's basically about having 2 classes, right? Each one of them will correspond to the correct kind of student. Maybe we got one class for resident students and the other one for non-resident students. That's what we did earlier. So now in this case, we can do something similar to that. We can say we got one class for domestic residents, one for domestic non-residents, and etc. We got 4 different classes. Okay, but what will be the consequence? So let's now recall how we actually declare the student management system class for design number 2. In that case, we just cannot have a single array to actually store the mixed kind of students for all the 4 kinds. In that case, what we have to do is to say under the students management system class, what you have to do is you have to declare, for example, domestic resident students. So that'll be one array. Let's say array number 1. And also domestic non-resident students array. So that'll be array number 2. So the number of arrays you have to do corresponds to the number of kinds of students you have, right? And also foreign resident students, array number 3, and also foreign non-resident students. That will be array number 4. Right? So accordingly, whenever, let's say if you want to register a common course for all the students, what you have to do is you have to repeat the same for loop pattern to go over this array, this array, this array, and this array. So the number of times you have to repeat will correspond to the number of kinds of students you have. And also you gotta duplicate the counters, you gotta duplicate the mutated method for adding the students into the corresponding array, right? That's something we spoke about earlier. So in this multi-layer hierarchy, you can see the drawbacks that we spoke about for design number 1 and number 2, they will be amplified, right? It's actually get even worse. So that's really something I want you to reflect. So that's why we really want to adopt the ultimate solution using inheritance. All right, finally, let's talk about what's going to happen if we try to do for design number 3. Design number 3, well, it's going to be, we got students being the class, and then domestic student, for example, is going to extend. So the arrow over here really corresponds to the extends syntax, right? I'll just do one of them for you, just extends. And more to it, remember about the code reuse. From the code reuse perspective, inheritance is actually very nice for you to actually use the extends keyword, and also you can refer to the parents version of the methods that's inherited to you by using the super keyword. That's what we spoke about. So just give you one example. How should we consider the definition for domestic students? Well, domestic student number 1 is going to inherit, let me just use a thinner pen. Number 1 is going to inherit all non-private attributes and methods from students. Everything that's declared in its parents over here for students is going to be inherited. Okay. And point number 2, as I hinted in part of the reflective question over here, where are the common attributes and methods stored over here? And let's say if we are talking about domestic students, you should really store the common methods and attributes among domestic resident students and also domestic non-resident students. So these are the 2 subclasses under domestic students, right? You will actually store common attributes and methods for domestic resident students and domestic non-resident students. Of course, for number 2, it might also mean you want to declare maybe some extra attributes or methods that's only specific to these 2. It's actually possible. Okay, it's a very important facts for you to actually recall about this particular design. All right, so that's about the very first example where we got more than 2 levels for the hierarchy. Let's see another example. Okay, another example. Let me go back to the slides, and that's also one example which I will use extensively, especially when we talk about typecasting. But let's now get familiar with this hierarchy first. It's about smartphone, and I try to update all the latest model for the phone. It's not really important, but I think it's not nice for you to see that how you can simulate the reality by using multi-level hierarchy. I think this one is even more sophisticated than this one over here. So we're gonna focus. We're gonna see more examples from this one here. Let's take a look. I have the same 3 reflective questions about the 3 designs that we have discussed. I'll leave the answer to you. I already spoke about for this simple case. You can think about how they should be discussed in this more sophisticated example. Okay, I want to just go over the hierarchy together quickly with you. Let's see. So you can see at the top we got smartphone over here, and then let's say, so this will be the root of the hierarchy. Inside there we actually got 2 let's say methods. We got dial, and also we got surf web. So what that means is any smartphone, including iPhone SE, iPhone 13 Pro, Huawei P50 Pro, and also Galaxy S21. So all the phones over here at the bottom, they should inherit the dial and surf web functions. So this is the common functions or common features or common methods that should be shared by all the smartphones, despite the platforms, either iOS or Android. And under which we actually got another two subclasses. We got iOS and also Android. So here iOS, we're also going to define some extra common attributes or methods that will be shared by iPhone specifically. So what do we have over here? So here you can see we got surf web. Surf web over here is actually overridden. So let's say we're going to override the surf web function by saying by default in iOS we're going to use Safari browser. Whereas for surf web function here for Android, it's going to be supported, but it's going to be overridden by using Firefox. Okay, this is a little bit hypothetical, just make some illustration for illustration purpose. And also we got FaceTime over here. So this will be some new function that's only supported by iOS, let's say. And also we got Skype, which is also a new method that's actually supported by Android and also all the Android phone over here. But notice that Skype over here is not supported by smartphone in general, meaning that we don't really expect every smartphone to be able to support Skype or FaceTime. We only expect, for example, every iOS phone to support the FaceTime, but not the other way around for smartphone. Okay, that's important to note. Okay, let's go a little bit more. You can see here we got, let's say for iPhone 13 Pro, we got something called Quick Take. But if you look up the latest specification, they have some new technology called cinematic mode to actually have a better quality if you do the quick take feature. And also, let's say under Huawei, let's say for Huawei P50 Pro, let's say we got a new feature they call Zoomage, which only exists for this particular type of phone. You can see this Zoomage does not exist for Huawei in general. And also, of course, it does not support for the sibling over here, right? It only supports for this specific model over here. And the feature they use, you can also look it up. It's called dual matrix camera over here. Okay, one more. You can see for Samsung, we say every Samsung phone will support the feature called Side Sync. Okay, you can see Side Sync over here only support for Samsung brands. Okay, either Galaxy S21 or Galaxy S21 Plus. But it does not exist for Android phone in general, only for Samsung. It does not exist for Android, so that it therefore it does not support in Huawei in general. It also does not support. It's not supported by iOS, right? So that's the hierarchy I would like you to actually get familiar with. I will also make the amplified version of the diagram available to you, so you can take a look. Okay, just get yourself familiar. For this week, we are not going to use this diagram so much, but once we get to next week, when we talk about typecasting, we definitely need it a lot. So make sure you get yourself familiar.